This video is about circular motion. To study circular motion, we're going to look at a planet orbiting the Sun in a circular path. Any object moving in uniform circular motion has constant speed. The direction of that speed, however, is always changing, so the velocity is changing. A change in velocity is also called acceleration. The object is accelerating towards the center of the circle. You may wonder why the planet is not just pulled straight into the Sun, but the component of velocity at right angles to the radius prevents this. According to Newton's laws, for the planet to accelerate inwards, a force must act inwards as well. That force is called the centripetal force. It acts towards the center of the circle, like the acceleration. This makes it perpendicular to the object's velocity. In this case, the force acting towards the center is gravitational attraction. This is the centripetal force. However, in different scenarios, other forces act as the centripetal force. For example, if someone is swinging a ball on a string in a circular path, the centripetal force is tension in the string in this instance. You need to be familiar with how changing variables affects others in circular motion. If the centripetal force increases in size for an object with constant mass, the object's speed may increase while radius stays the same. Or, if we go back to our original setup and the force increases, then the radius of the circular path will decrease when speed remains constant. Going back to our original scenario, what if the object in circular motion had a greater mass? Well, in this case, to maintain the same radius and orbital speed, centripetal force must increase. Okay, let's take a look at a typical two-part question on this topic. A racing car drives in a circular path on a circular track. First, we are asked to explain why the car's velocity changes, but its speed is constant for 2 marks. Let's remember that velocity is a vector. It has magnitude and direction. Writing that down gains our first mark. Speed has magnitude but no direction. So for changing velocity but constant speed, it has to be the direction that changes, while magnitude is constant. That's our second mark. Next, we need to identify the centripetal force in this scenario. We are asked to draw an arrow on the diagram representing centripetal force. Then, we must explain how we arrived at our answer, all for 4 marks. Remember that centripetal force is the one causing acceleration towards the circle's center. In this case, it's friction on the tires causing this, which is our first mark. When drawing the arrow representing force, make it very clearly point from any car but to the center of the circular path. That's mark 2. Now to explain our answer, recall some properties of a centripetal force. It must act towards the center of the circle, and it must be perpendicular to the car's velocity. That's 6 easy marks if you can remember all of your definitions. This topic builds on Newton's laws, so go back and revise them if this all feels like it's a bit much. In a circular path, velocity changes while speed remains constant. This is caused by an ever-changing direction of velocity at a constant magnitude. Changing velocity means objects on a circular path are always accelerating towards the center. This acceleration is caused by a centripetal force. You must understand how changing force, speed, radius, or mass of the object in circular motion affects all the other quantities.